Hello, this is Ms. Shinners, and I'm going to talk you through the first page of the review packet. So, starting with number 1 here, we can see that it's back from Unit 1. So that was the unit about trig review. SOHCAHTOA, right? Sine is opposite over hypotenuse, and cosine and tangent, and those things. So I'll give you a moment to read through part 1, question 1. You can see here that we have a triangle situation here. So when we're solving triangles, we have really 3 tools in our toolbox. We can use trig, such as sine, cosine, tangent, or the Pythagorean theorem. But these trigonometric tools are only good for right triangles. So because this is obviously not a right triangle, we're not going to want to use these tools. The next tool in our toolbox that we covered was law of sines. And if you remember, the law of sines states that the sine of any angle divided by the side across from that angle. So for example, if this angle is P, then this would be the side P. And if this angle is Q, then this side would be the side across from it, right? And if this angle is R, then this would be side R. So you kind of think about the sine of an angle divided by the side across from it should equal the sine of another angle in that triangle divided by the side across from it. So in this case, we're trying to solve for side R, and I know that the sine, right, the angle across from it is 80, but I don't know these other 2 angles, so I'm going to have 2 unknowns, right? So I don't think law of sines is what we're going to want to use. Our last tool that we discussed was law of cosines. And if you remember, this theorem looks a lot like the Pythagorean theorem, but then it's minus 2ab cosine of c. And again, this side c is across from this angle c. So the angle and the side across from it should be using the same letter. Let's check out our situation. I know 2 sides, right? A and B, that could be Q and P, right? And I know the angle across from my unknown side, right? I don't know R, but I know that this is 80 degrees. So it looks like law of cosines is going to be the one that works. So let's plan to use that. And so again, law of cosines is this equation here. So looking at my picture, this would be little r squared equals, right, we said this was little r, equals 50 squared plus 60 squared minus 2 times 50 times 60 times the cosine of 80 degrees. And again, the important part is that this angle is across from this side, and this angle is across from this side. So we're good to go. If you just plop that right into your calculator and take a square root, you should get about 71.1 feet. So that is the correct answer there. That is what R equals. Awesome. Let's move on to number 2. So arc length is another equation that we talked about a long while ago, but maybe you remember it, maybe you don't. Arc length is denoted with an S I have no idea why. That seems to not make any sense to me, but it is. And arc length equals the radius of my circle times the angle that is being intercepted. So let's think about our first one here. So if I have a circle, the radius is 4, and the angle is 60 degrees. So that means this is 60 degrees. I want to find the arc length. That's the crust or a part of the circumference of my circle. And that's what I'm trying to solve for, that little segment in red there. Now I know my radius is 4, right? But I cannot put in 60 degrees. The angle has to be in radians. Maybe this is coming back a little bit. We do have to be in radian mode. We have to be in radians because this equation falls from us knowing that a radian is equal to the ratio between arc length and the radius of my circle. So that's really how we get this equation here. And since this is in radians, my angle also has to be in radians. So let's quickly convert 60 degrees into radians. If you don't know off the top of your head what that equals, you could multiply it by pi over 180. However, most people I think will start to remember from your unit circle, 60 degrees is just pi over 3 radians. So let's plug that into my equation here. And it looks like my arc length will just be 4 pi over 3 radians. And I can just leave it right like that. I can't simplify anything. Now you could punch that into your calculator and get me a decimal, but I would prefer your answer just in pi. The only thing is I made a mistake. Arc length is not measured in radians. It's measured in whatever measurement we're in. And in this case, we're in meters. So I do apologize. It should be 4 pi over 3 meters. So that's your answer to number 1. I'm going to erase some of this to give us some room. And we can work on part B here. So again, my equation is S equals R times theta. I know that my radius is 4, and my angle's already in radians, so I can just multiply it by pi over 2, and simplifying that, I should get 2 pi meters. Similarly, in part C, I know my radius is 4, and my angle's already in radians, so I can just plug it in just like that. 4 times 3.5 should give me 14 meters. And on the last one here, hopefully you don't just plug in 450 because we do have to convert that into radians first. To convert it to radians, it's just pi over 180. So that would give me, canceling out those zeros, 45 divided by 18. That will simplify to be 5 over 2. Yeah. Divide both sides by 9. Divide top and bottom. 5 over 2 pi. Awesome. So now plugging this into my equation, I would get 4 divided by 2 is 2. 2 times 5 is 10 pi meters. 10 pi meters. So the big thing to remember about arc length, here's my equation, but the big thing you have to remember is that the angle has to be in radians. So make a mark right now. Angle is in radians. Because even though you'll be given this equation on the test, if you don't remember it has to be in radians, then that's not going to be very helpful. Awesome. Moving on here. Ooh, everybody's favorite, linear and angular speed. So this one's going to take a little bit, so I'm actually going to pause the video and start a new one. to talk through linear and angular speed.